Right, okay, we're looking at volumes of cuboids. Of cuboids. Right, you know how to calculate the volume for cuboid. The world's greatest artist. Right, okay, just say that is 2 meters, that is 3 meters, and that is 4 meters. So the volume, remember we said you multiply 2 times 3 to give you the cross-sectional area. So we're going to do 2 times 3 first, which is 6. Then we multiply it by the depth. Right, so we multiply it by 4. And the answer is 6, 12, 18, 24 meters cubed. Remember it's cubed? Yeah, remember it's cubed. That's easy. Now you try this one. If I said this to you, and then just once I've drawn it, labeled it, you try it, pause it, try it on your own, and then we'll do the same thing again. So if I said to you that is 4, that is 2, and that is 10. So what would you do? Right, just pause it there. Right, okay. So what we do is we take 4 times 2 to give us this cross-sectional area. Just want you to get used to the words cross-sectional area or cross-section, yeah. So what we've done is we've done 4 times 2, we've done that bit. Then we multiply it by the depth, which is 10. So it'll be times 10. And that will give 4 times 2, whatever, 4 times 2 is 8 times 10 is 80. And what are the units? What do we measure volume in? Cubic meters or meters cubed? Let me write those words down, right? So when you've got a little 3 there, it's called meter cubed or meters cubed or cubic meters or meter. Right, now we're going to stretch it a bit further. Now I'm going to use the same example. I want to work at the volume. I know it's 4 times 2 times 10. And the answer is, oh my god, did I put 80? Right, okay. The answer is 80 meter cubed. I'm not interested in the units at this moment in time. Now, what I'm going to do is I'm going to hide this. You don't know what this is now. I'm just going to put in there X meters. So you don't know what that is. Now if I come down here, I know the 4, I know the 2, but this I don't know. I'm going to hide this now. I'm going to pretend I don't know this. So what I'm going to do is I'm going to rub it out. And I'm going to put in times X. Right, this is where you start doing algebra. But you're doing it in your head. Because if it's simple algebra, you can do it in your head. You do it all the time, really. Yeah. We're going to start doing algebra. Where an unknown number is shown by the letter X. It can be any letter, but we're going to use X. So now the question is 4 times something 4 times 2 times something equals 80. Step 1, I'm going to multiply these two. I know 4 times 2 is 8 times something is 80. So that's my first step. Can you see what I've done? I've multiplied these two numbers that they've given me. Now, when the numbers are easy, you can do it in your head. It's not a problem because I know 8 times 10 is 80. But if it gets a bit more difficult, what you do is you take this number 80 and you divide it by this number here on this side. So I know x is equal to 80 divided by 8. I like to write it like this because it's easier for me to think. How many 8s are there in 80? The answer's 10. So I now know that this dimension here is 10 meters. But we already knew that. We knew that from here. Right, let's do one. Let's do one here. I've got a cuboid here. That is 5 meters, that is 2 meters, and that is x meters. It can be in any order. Right, I know that the volume V is 50 meters cubed. So I know, now look at this, I know 5 times 2 is 10 times something equals the volume, right? So I know this, so watch this, I know V equals 5 times 2 times x. Remember we said x is the unknown. We don't know this number. We're trying to find that out. But I do know V. And what is V? They've told us V is 50. So I'm going to, instead of putting V, I'm going to put 50 equals, and then what is 5 times 2? 10. And then I put this down here, times x. Now what did I do with these two numbers? So I'm going to divide the volume. I'm going to divide the volume by 10, this number here. So I'm going to write it out like this. Look, 50 divided by, I like that line, 10. How many 10s are there in 50? 5. So the answer is 5 meters. Right. See if you can do this one here. Let's change colors. Let's change colors so then you don't get confused. You do this one. Now, because this all you're doing is you're rearranging a formula. So if I said to you that is 3 meters, if I said to you that is 4 meters, if I said to you this is x meters, and then if I gave you the volume V as I don't know, 24 meters cubed, how would you do this? So pause this for a second and try it yourself. Right, I know the volume is 24, so I'm going to write that equals, I know I'm going to multiply the two numbers that have been given here, the two dimensions, the two lengths, 3 times 4, and then I'm going to multiply it by the depth times x. I need to solve this. So equals under the equals, 24 stays as it is. I know 3 times 4 is 12 times something. There you go. Now I need to solve this. So I do 24 divided by this number always, the one that's attached to the x or the unknown. So it'll be 24 divided by 12. How many 12s are there in 24? If I did the 12 times table, it's 2, isn't it? So I know x equals 2. So I know this dimension here is 2 meters. Okay, I'll leave one question for you, and then that'll be brilliant, actually. It's the same idea, but I'm going to change the dimensions now. I'm going to call this 3. I'm going to call this x. I'm going to call this 10. And I'm saying to you that the volume is what we'll do is we'll call it 90 meters cubed. And you try that now then. Okay, well done.